Hi everyone, welcome to the Simplilearn's YouTube channel. Want to build powerful AI agents but not sure which tools to use? LangChain lets you turn the large language models into practical, reliable AI agents. Think of it as a framework that organizes and guides a model so that it can produce exactly what you want consistently. We will cover the fundamentals, chains, tools, agents, and observability, and explore real products like Langsmith and open source frameworks like LangChain, LangGraph, and deep agents. Then we will move on to hands-on, where we build AI agents that generate social media content automatically. By the end, you will know how to design, test, and deploy your own intelligent AI workflows, which are ready for real-world applications. That said, if these are the type of videos you'd like to watch, then hit that like and subscribe buttons along with the bell to get notified whenever we host. Also, just that you know, if you want to upskill yourself, master generative AI and artificial intelligence skills, and land in your dream job or grow in your career, then you must explore Simplilearn's cohort of various generative AI courses and certifications. Simplilearn offers various certification programs in collaboration with world-leading universities like Purdue University, IIT Guwahati, and many more. Through our courses, you will gain knowledge and work-ready expertise in skills like advanced Python, machine learning, generative AI, and over a dozen others. That's not all. You also get the opportunity to work on multiple projects and learn from industry experts working in top-tier data and product companies, and also academicians from top universities. After completing these courses, thousands of learners have transitioned into an AI and machine learning role as a fresher or moved on to a higher paying job and profile. If you are passionate about making your career in this field, then make sure to check out the link in the pinned comment and description box below to find a generative AI program that fits your experience and areas of interest. Now, without further delay, let's get started with a small quiz. In LangChain, what is the primary purpose of a prompt template? Your options are A. To connect multiple language models together, B. To define and structure input instructions for a large language model, C. To deploy AI agents to production, and D. To store data in a database. Please do let us know your answers in the comment section below. Let's start with a small question. Everyone is talking about large language models, ChatGPT, Gemini, Claude, and a lot more. But once you move beyond chatting, you quickly realize something more important. Models alone don't build real applications. Real applications need memory, tools, workflows, monitoring, reliability, and a lot more. That's exactly where LangChain comes into the picture. LangChain is not just a library. It's an ecosystem designed to help developers and teams build reliable, controllable, and production-ready AI applications, especially those based on LLMs. In this session, I'll explain what LangChain actually is, why it exists, how it helps build reliable AI agents, and the key products in LangChain ecosystem, which are LangChain, LangGraph, Langsmith, and deep agents, all in simple and practical terms. So let's start with what is LangChain. At its core, LangChain is a framework for building applications powered by large language models. But thinking of it as yet another AI library, think of LangChain as a glue layer between large language models, your data, external tools, business logic, and real users. When people first use an LLM, they often write a single prompt and get a response. That's fine for demos, but real-world applications require much more. Things like multi-step reasoning, calling APIs, fetching data from databases, remembering past interactions, handling errors, and behaving consistently over time. LangChain gives you structured building blocks to do exactly that. Now, why LangChain exists could be a question. Large language models are powerful, but also unpredictable. They can hallucinate, they can give you different answers to the same question. They might remember, or most of the cases, they don't remember things unless you design a specified memory for that. They don't naturally follow workflows. LangChain exists to turn probabilistic models into deterministic systems. Instead of hoping the model behaves correctly, LangChain helps you control how the model is used, break tasks into steps, and add the guardrails, track what happens under the hood, and a lot more. This is what makes AI systems usable in real products and not just experiments. Now, let's go through the core idea of LangChain. So we have three: chains, tools, and agents. LangChain is built around these three core ideas. So let's go through them one after the other. First, chains. A chain is simply a sequence of steps. For example, take input from the user, reformat it, send it to an LLM, post-process their response, and lastly return a final answer. Instead of writing messy, unstructured code, LangChain lets you define the flow cleanly. Chains make your AI logic easier to debug, easier to test, and easier to extend. Now the second core component, which are tools. Tools allow a large language model to interact with the outside world. For example, we have search engines, databases, APIs, calculators, and some internal company systems as well. Without tools, a model can only talk. With tools, it can act. That's the important difference. LangChain provides a standard way to define tools so the model knows what tools are existing in the system, when to use them, what inputs they require to process a request. Now the third core component, which is agents. An agent is where things get interesting. Agents allow the model to decide what action to take, choose which tool to use, observe the result, and decide the next step. In simple terms, agents add decision-making ability, but agents also introduce risk because now the model is in control of execution. This is why reliability and observability becomes critical, which brings us to the LangChain's ecosystem. Now, how LangChain helps build reliable agents? Agents are powerful, but unreliable agents are dangerous. LangChain tackles this problem in several ways. One of those is structured control. Instead of letting the model to do anything, LangChain enforces defined tools, defined input and output formats, controlled execution paths, and a lot more. This reduces randomness. Another one is state and memory management. LangChain provides built-in support for conversation memory, session state, long-term context, and a lot more. This ensures that the agent behaves consistently across interactions instead of forgetting everything. Now, another one is deterministic workflows with LangGraph. This is where LangGraph comes in. LangGraph allows you to design agent workflows as graphs, not just loose loops. You can define states, transitions, conditions, failure handling, and a lot more. Instead of the agent decides everything, you design how the agent is allowed to think. This is critical for enterprise systems, compliance-heavy applications, multi-step automation, and a lot more. Now, the next stage is where we discuss open source frameworks in the LangChain ecosystems. Let's talk about the key open source components. First one, LangChain, the core framework. This is the foundation. LangChain provides prompt templates, chains, memory abstractions, tool interfaces, LLM wrappers, and a lot more. It allows you to switch models easily from OpenAI to Anthropic to open source models and a lot more without having to rewrite your entire application. Think of LangChain as the backend framework for LLM-powered applications. The second one is LangGraph. LangGraph is built specifically for AI agents and workflows. Instead of linear chains, you define nodes, edges, conditions. This makes AI agent behavior predictable, debuggable, and safer. LangGraph is especially useful when multiple agents collaborate, long-running tasks are involved, and you need human in-loop approvals. Now comes the third one, deep agents. Deep agents focus more on autonomous, multi-step reasoning systems. They are designed for research assistance, planning systems, complex decision makings, and a lot more. Deep agents emphasize iterative reasoning, reflection, goal-driven execution. But again, the key idea is control, not blind autonomy. LangSmith is for observability, evaluation, and deployment. Now, let's talk about LangSmith, which is a critical part of the ecosystem. LangSmith is not just a logging tool. It's an AI observability and evaluation platform. What LangSmith solves when an AI agent fails? You need answers. What prompt was used? Which tool was called? What did the model think? Where did it go wrong? And a lot more. LangSmith gives you visibility into traces, tool calls, model inputs and outputs, latency and errors, and a lot more. This is essential for production systems. Now, let's focus on evaluation and testing. LangSmith allows you to run automated evaluation, compare prompt versions, test model changes, measure quality over time. Instead of guessing whether your agent improved, you can measure it. Deployment and agent builder. Langsmith also supports deployment workflows, agent configuration, version control for prompts, and logic. This turns AI development into an engineering discipline, not trial and error. Now, let's focus on why LangChain matters in real-world applications. LangChain is widely used because it addresses real pain points. Companies use LangChain for customer support agents, internal knowledge assistants, data analysis co-pilots, workflow automation, and research tools, and also a lot more. The reason it works is simple. LangChain respects the limitations of LLMs instead of ignoring them. It assumes models can fail, prompts need iteration, systems need monitoring. That mindset is what makes it production ready. Now, let's go through some final thoughts and a quick summary. LangChain is not about hype. It's about engineering discipline for AI systems. LangChain gives structure. LangGraph gives control. Deep agents give autonomy with guardrails. Langsmith gives visibility and confidence. Together, they allow teams to move from let's try an AI demo to let's run an AI system in production. If you are serious about building reliable, scalable, and maintainable AI applications, understanding LangChain is no longer optional. It's foundational. Now that we understand what LangChain is and why it exists, the next logical step is to apply these ideas into a real problem. In theory, we talked about chains, tools, agents, and observability. But these concepts only start to make sense when you see them working together in actual use case. So in this project, we are going to build an AI content creating agent for social media platforms using LangChain. The goal is simple and practical. Instead of manually brainstorming post ideas, captions, hashtags, and content angles every day, we will design an AI agent that can understand a content brief, analyze the target platform and audience, generate platform-specific content, iterate and refine outputs based on simple rules. This project is not about building a flashy bot. It's about learning how to structure an AI system that behaves consistently and produces usable content. As we build this agent, you will see how chains help break content creation into clear steps. Tools allow the agent to fetch context and guidelines. Agents decide what type of content to generate, and observability helps us understand why the agent made certain choices. By the end of this hands-on exercise, you won't just have an AI that writes posts. You will understand how to design, control, and improve an AI agent using LangChain skills that directly translate to real-world AI applications across industries. Now, let's move on from concepts to code and start building. Before we look at the actual code, it's important to understand the basic project structure. These supporting files may look simple, but they play a critical role in making the AI agent stable, secure, and reproducible. First, we have the VenV, the virtual environment. The VenV folder represents a virtual environment. In simple terms, it is an isolated workspace for this project's Python dependencies. Now, why this VenV space matters? Different projects often need different versions of the same library. Installing everything globally can break other projects. A virtual environment keeps this project clean and independent for this LangChain agent. All LangChain related libraries like LLMs, SDKs, supporting utilities are installed only inside this particular virtual environment. Think of VenV as a sandbox or virtual machine where this AI agent can run without interfering with anything else on your system. Now, the second one is .env file. So this particular .env file or environment configuration file is used for storing sensitive and environment specific information. Typically, it includes API keys from OpenAI, Gemini, etc., model configuration values, environment flags like development or production. Now, why this is important? You never hard-code secrets into your code. You can change configurations without touching the logic. It keeps your code safe and portable. For this project, the .env file allows the AI agent to authenticate with the language model provider, access external services securely, and in short, .env separates the configuration from logic, which is the best practice in production systems. The third one is requirements.txt, the dependency definition. The requirements.txt file lists all the Python packages required to run this project. This usually includes LangChain model, SDKs, utility libraries like Python.env, etc. Now, why this matters? Anyone can recreate the same environment. Deployments become predictable. Version mismatches are avoided. If someone clones this project and runs pip install requirements.txt, they get the exact setup needed to run the code context generation agent. This file ensures consistency across machines, teams, and environments. Now at last we have our main file, which is socialgen.py, the core application logic. This is where the actual intelligence lives. The socialgen.py file contains the LangChain setup, prompt logic, chains and agents, tool definitions, execution workflow, and content generation. Everything we discussed in theory, chains, tools, agent workflows, comes together in this file. You can think of socialgen.py as the brain and execution engine of the AI content generation agent. All other files exist to support and safely run this file. Now, the big picture. Together, these files create a clean production-ready system. When-v is for isolation and stability, .env for security and configuration, requirements.txt for reproducibility, socialgen.py is for business logic and intelligence. Once this foundation is clear, reading and understanding the code becomes much easier because you know where configuration ends and execution begins. Now, we can step into socialgen.py and start breaking down the actual agent logic one section at a time. Now, let's start with the code. So here, let's select all the imports we have. Let me select this. Let's start through the snippet slowly and practically, focusing on each line exists rather than just what happens with the imports. This section is mainly about setting up the environment and core building blocks before the AI agent does anything. So here we have from future import, import arcpass, import OS, systems, and a lot more. This line is about future-proofing the code. In simple terms, it allows Python to treat type hints as plain text instead of immediately evaluating them. This helps avoid circular reference issues and improves compatibility with modern Python features. Now, why it matters here? LangChain-based projects often use complex objects and type hints. This import ensures the code remains clean, flexible, and compatible as the project grows. You can think of it as prepare Python to understand modern structured code. Now, the standard library imports. These are all built-in Python tools and each one serves a practical purpose. arcpass. It is used to read inputs from the command line and allows you to run these scripts like Python, social, gen, py, platform, Instagram, topic is AI, right? This will be the final command that we will be delivering to get our output. Now, why this matters? It makes the AI agent reusable and configurable. You don't have to hard code values like platform or content type. The next one is OS. This command helps to interact with environment variables and operating systems commonly used to read values from the .env file. Now, example use cases, fetching API keys, checking environment settings, etc. Now, the next one is sys. It gives the access to Python's runtime information, often used for error handling, exiting the program safely, debugging execution issues, and a lot more. This is more about control and safety with AI logic. The next one is path from pathlib, a modern way to work with file paths, cleaner and safer than string-based paths, and why it matters could be a question. It makes the script platform independent, ensures file handling works the same on Windows, Mac OS, or Linux. Now the third one, LangChain core components. So here we have from langchains.chains, import LLM chain, from langchain.prompts, import prompt template, and a lot more. This is where LangChain enters the picture. Prompt template. This defines how prompts are structured. Instead of writing raw prompts repeatedly, a template defines placeholders, ensures consistency, and makes prompts reusable. In this project, prompt templates will control how social media content is requested. This avoids vague and inconsistent instructions to meet model. Think of it as a form that AI fills every time. Now we have LLM chain. An LLM chain connects a prompt template, a language model, optional memory, or output parsing. This is the simplest form of a controlled AI workflow. In plain English, input goes in, prompt is formatted, model responds, output comes out. For a content creation agent, this is the core execution unit. Now the fourth one, Google Gemini model integration. From LangChain, Google Gen AI, import chat Google Generative AI. This line connects LangChain to Google's Gemini models. And why is this important? LangChain itself doesn't provide models. It provides standardized way to use different models. With this import, you can swap models later without rewriting the entire logic. The agent becomes model agnostic. In simple terms, LangChain handles the how and Gemini handles the thinking. Now the fifth one is environment variable loading. The code is from.env import load.env. This allows the script to read API keys, load configuration from the .env file. Why is this critical? It keeps the secrets out of the source code, makes the project safer to share or deploy. When load.env function is called, the API keys become available for the program. The model can authenticate successfully. Now, the big picture view. The entire snippet is about preparing the ground before the agent runs. It sets up the safe configuration handling, clean prompt construction, a controlled AI execution workflow, connection to the LLM. Nothing intelligence happens yet, but without this setup, nothing reliable can happen later. Once this foundation is in place, the rest of the file can focus purely on content generation logic. Now, we will select the next line, which is about the platforms. So we will be dealing with the platforms which are Meta, Instagram, LinkedIn, and YouTube. So our agent will help us write content for these 4 platforms as of now. But we can also customize this to more based on our future requirements. Now, let's go through the code of definition, right? So the entire code section, let me highlight it for you. This is really important. Here is where we define everything for YouTube, for LinkedIn, for Instagram, and for Meta. Let's go through this one step at a time. These are the templates for us. This function is the first layer of control in your content generation agent. What this function is, it is trying to solve different social media platforms behave very differently. What works on LinkedIn and Instagram, Twitter cannot be generated using the same prompt. This function exists to accept a platform name from the user, validate it, prepare the ground for platform-specific prompt, and in other words, it prevents the AI agent from generating generic or incorrect content. Huge signature. We have definition platform, prompt, platform string, and prompt template. This tells us 3 important things. The function expects a platform name as input. The input should be a string. The function will return a prompt template. So this function's job is not to generate content. It's to prepare the instruction for content generation. Cleaning the input platform is equals to platform.strip method. This line removes extra spaces, accidental formatting issues, and why this matters? Users may pass space Instagram instead of just Instagram. Without this, valid inputs could fail validation. This is a small step, but it improves robustness and user experience. Now, next one is platform validation. If platform is not in platforms, here the function checks whether the platform is supported or not. Platforms are likely predicted, such as the list we have, which is Instagram, LinkedIn, Twitter, etc. Right? Now, why this is important? AI agents should not guess platform behavior. Unsupported platforms may lead to incorrect tone, length, or format. This is a guide rail. Next is clear error handling. Raise value error, unstop platform, choose one of the joint platforms. This particular code segment is really important. Instead of failing silently, the code stops execution immediately, explain what went wrong, tells the user what values are allowed and what are not. From a systematic design perspective, this is crucial. Errors are caught early. The agent never runs the invalid assumptions. In simple terms, if the input doesn't make sense, don't let the AI continue. Why this matters for an AI agent? This function demonstrates a key principle of reliable agent design. AI systems should validate inputs before invoking a model. AI systems should validate inputs before invoking a model. By doing this, you reduce hallucinations, you improve consistency, you maintain control over inputs and outputs. This function ensures that AI agent always knows which platform is writing for. The prompt logic that follows is platform aware. The big picture role in the workflow. At a high level, this function helps you take user inputs, cleans it, validates it, prepares for a platform-specific prompt. It's a small function, but it plays a big role in reliability. Once the platform is validated here, the next part of the code can safely focus on how to write the content, not whether the input was correct or wrong. Now, let's focus on the next code segment. So I have highlighted the code segment here. This is a very important part of the project because this is where the agent behavior is actually shaped. I'll explain this in plain execution focused terms. So what is the code is doing here at a high level? This block defines platform specific prompt instructions instead of asking the AI. Write a social media post about X. We are telling it who to act as, what platform is it writing for, what tone to use, how the output should be structured, what to include and what to avoid. Now, this is the difference between random content and controlled usable content. The templates dictionary, Python templates dictionary string. This is a dictionary where the key is the platform name like Meta, Instagram, LinkedIn, YouTube, and the value is a detailed prompt template for the platform. Think of this as a prompt library. Each platform has its own audience behavior, its own content style, its own format constraints. Each template reflects that. Now, why is this approach important? Now, instead of writing separate functions for each platform or hard coding prompts through the code, we centralize everything in one structured map. This gives us consistency, easy maintenance, clear separation between logic and content. If you want to improve Instagram content later, you can update in one place. Now, understanding this prompt structure, each platform template follows the same idea, role assignment. For example, here we have text, you are social media writer. This tells the model who it is supposed to be. LLMs to respond how much better when a clear role because it narrows their behavior. Now the second one, task definition example. Text to write Meta or Facebook about the topic, and here the topic is the placeholder. It will be filled dynamically at the runtime. This allows the same template to work for any topic. Now the third one, tone control. Each and every platform has its own tone. Platform tone defines explicitly friendly and community first for Meta, energetic and punchy for Instagram, professional and credible for LinkedIn, and clear and retention focused for YouTube. This prevents tone mismatch, which is one of the greatest and most common failures in AI content generation. Now the fourth one is format constraints. This is the most critical part. Each template clearly specifies the number of lines or paragraphs, like hooks and CTAs, emojis and hashtag limits, character constraints. For example, Instagram allows many hashtags, LinkedIn restricts emojis, YouTube requires structured output with titles and chapters. These constraints reduce ambiguity for model and dramatically improves the output quality. Now, why the YouTube template is more structured? You will notice the YouTube prompt is very strict. For example, on the page here, text return exactly this format. This is intentional. YouTube content is often parsed further, displayed in dashboards, used for SEO and automation, and a lot more. By enforcing a fixed format, the output becomes machine readable. Downstream processing becomes easier. This is a good example for designing prompts for systems, not humans. Now, the next one is returning the prompt template. So here we have the code segment. Python return prompt template, input variables is equals to topic, template, and templates is equals to platform. This line converts a plain string into LangChain prompt object. What this does? It tells LangChain that topic is a required input, makes the prompt reusable, ensures the model always receives structured instructions. In short terms or in simple terms, this is the final step where strategy becomes executable. Now the next one is how this fits into an agent workflow, end to end. This block starts in this way. First, it selects the right platform. Second, applies the platform specific rules. Third, creates a reusable prompt template. And fourth one, feeds clean instruction to the LLM chain. This is prompt engineering done correctly. No vague repeats, no platform confusion, no random formatting. Now, some key takeaways from this particular code segment is the code is where the quality of your AI agent is decided. The model hasn't generated anything, but you have already defined its role, set its boundaries, controlled its output. That's exactly how you build reliable production-ready content agents with LangChain. Now, let's go through the next code segment, which is parse args. Now, I'll just select or highlight this particular code segment, and now we'll go through this line by line. This function is for the execution of your project. Everything we discussed earlier, templates, platforms, models, comes all together here. I'll explain this step by step, focusing on the execution flow, not just codes and tags. Now, first one, what this function does at a high level. So we have the code segment here which says Python def generate post, topic, string, platform, string, API key, string, etc. This function takes a topic, what the content is about, a platform where the content will be posted, and an API key to access the language model. And it returns a ready-to-use social media post as a string. In simple terms, give me a topic and a platform, and I'll generate the platform appropriate content. Why these parameters are keyword only? The star in the function signature enforces keyword only arguments. That's the reason. And why this matters? It prevents accidental misordering of values, makes function calls self-documenting, reduces runtime mistakes, and a lot more. Now we also have an example here which says Python generate post, top is equals to AI marketing, platform is LinkedIn, and API key is the key, right? And talking about the API key, we are using the Gemini 2.5 model, which is light, and this gives you 15 executions per minute. If you're going with the latest version, it will give you 5 executions per minute. So if you're going with a free model, then you should use the lighter version because it will get a higher cycle. So I'd recommend to go with the lighter version. So here we have the .env file. So this is the API key generated for the light version. So I'm using the version which is mentioned here. I think I had commented it. So here's the one. So the cursor AI will have global ignorance. So that will create a lot of ambiguity. So whenever you add the .env file with all the Gemini API keys, automatically it goes to a mode where features are disabled, file in global ignorance. You need to make sure that it is getting avoided. And to get multiple redundancies or multiple trials of executing this code in a free version, go with 2.5 flash light, which I've mentioned here. So it will give you 15 iterations per minute. So that is the best part to go with. If you're using a paid version and the latest model, then you don't have the problem of running out of resources. Now let's continue with the next one. This improves clarity and reliability, especially in larger systems. So we'll go through this step by step. The first step is initializing the language model. So here we have a code snippet which says Python LLM is equals to chat Google generative AI, and the model is 2.5, which we checked right a moment ago, 2.5 flash light. And we are measuring the temperature to 0.7. So here you can see the temperature. So what is the temperature? So basically when you code this generative AI model, if you keep the temperature very less, then it will give you robotic answers. If you keep it somewhere around 0.7 or 0.6, it gives you some human type of output, which is a little, friendly, and so it will have a little bit of aura catching you, your thoughts and everything. So keeping the temperature ideal between 0.5 to 0.7, it will give you human-like outputs from the AI model that you have created. Now let's go to the next one. This block sets up the thinking engine and model selection. Is Gemini 2.5 flashlight is optimized for speed, cost efficiency, short form content generation. This is a smart choice for social media platforms. Now, explicit API key parsing. This particular model is optimized for speed, cost efficiency, and short form content. This is a smart choice for social media posts, and now we will look at the explicit API key parsing. So we have a code snippet here which says Python Google API key is equals to the actual API key. And instead of relying on environment variables, the key is passed explicitly. And why is this important? This avoids hidden dependencies, makes behavior predictable, and easier to test and debug. This aligns with production-grade coding practices. Now, the most important part, you might be seeing temperature is equals to 0.7 here. We already discussed this. But again, so if you keep the temperature too low, we will have robotic output. If you keep it too high, then the inconsistent tone can be seen. If you have an ideal value, something ranging in between a 0.5 to 0.7, then it balances the creativity, control, and brand safety. Now, let's go into the step number 2, which is about the fetching the platform-specific prompt. So in the code snippet, like Python prompt is equals to, here the platform is validated, the correct prompt template is selected. This ensures the model receives clear instructions, the output matches platform expectations, and all the parameters are achieved. At this point, the system knows what's it writing about, where it will be posted, how it should sound. Now we have the step number 3, creating the LangChain execution flow. So we have a code snippet, Python chain is equals to LLM chain method, and inside that we have LLM is equals to LLM and prompt is equals to prompt. This is where LangChain shines. You are explicitly defining the input, which is the topic, processing, which is prompt plus model, and output, which is the final generated content. No magic, no hidden steps. Think of LLM chain as a controlled pipeline for text generation. Now, we have the step number 4, which is about running the chain. We have a code snippet, Python return chain dot the topic and the strip method. This line does several things. First, it injects the topic into the prompt template. Second, sends the final prompt to the model. Third one, it receives the generated output. And the fourth, cleans up the extra white space. And lastly, returns the final content. At this point, the agent has completed its job. Now, why this design is strong? This function demonstrates good AI system design principles, clear inputs, explicit configurations, platform-aware prompts, controlled creativity, simple, testable execution. There is no agent over-engineering, just clean, deterministic chain. Now the big picture of this execution flow, end to end. Now this is what happens. First, user provides topic and platform. Second, platform rules are applied. Third, prompt is constructed. Fourth, model generates content. And last, fifth step, output is returned cleanly. This is exactly how you move from LLMs are powerful to LLMs are usable in real applications. Now, let's go through the key takeaways. This function is a bridge between theory and results. It shows how LangChain reduces complexity, improves reliability, makes AI behavior more predictable. From here, you can easily add logging with LangSmith, convert this into an AI agent, expand to multi-step workflows. Now, let's go to the next code segment here. I'll highlight that. So this function is about how a human interacts with your AI agent. Up to now, we focused on prompts and models. Here, we focus on usability, safety, and control, especially when running the script from the command line. Let's break it down. So the first one, what this function does at a high level. So we have a code snippet here. This function reads command line inputs, validates them, converts them into a structured object. In simple terms, this is how we tell the AI agent what to do. Instead of hard coding values inside the script, this allows you to run it dynamically. For example, bash python socialgen.py, you can give a topic name like AI healthcare and a platform which can be anything like LinkedIn that we have in our list. Why command line arguments matter? Here, using command line arguments make the script reusable, enable automation, fits well into pipelines and CI/CD. This is a small step towards production readiness. Now let's go through a few steps. Step number one, creating the argument parser. So here we have a sample script. Python p is equals to argparse.argument parser function and description is equals to generate platform specific social content using any of the LLMs like Gemini. This line initializes a parser and describes what the script does, automatically generates helpful usage messages, and if someone runs the script incorrectly, Python will guide them instead of failing silently. Now, step number two, topic argument. We have a sample snippet. Python p add argument and topic required is equals to true, help is equals to topic for post, example AI in healthcare. This defines the core input for content generation. Why it is required? The AI cannot generate content without a topic. It avoids meaningless or empty prompts. The help text also improves clarity for users. So you can see a help text written right here. And now the step number three, platform argument. So we have a sample argument here. Python p add argument, platform required is equals to true, choices given the platforms, help target platform which can be Meta, Instagram, LinkedIn, YouTube that is specified in our code segment. This is critical reliability feature. By using choices, that is the given platforms, only supported platforms are allowed. Invalid inputs are rejected immediately. This works together with platform prompt function to enforce platform correctness at multiple levels. In plain English, you can't ask the agent to write for a platform it doesn't understand or if we haven't mentioned in the selection. Now we have the step number 4, which is API key argument. So here we have the line which says, what happens if omitted, right? So if Google API is omitted, you can read the variable from the .env file. This gives flexibility in how API key is provided in two supported modes. The first one, pass the key directly via CLI, which is command line interface, or store it securely in a .env file or environment variables. Why is this good design? It works in local development, works in cloud or CI environment, and most importantly, keeps the secrets out of the code. Now comes the step number 5, which is parsing and returning the arguments. This line reads the actual command line input, validates everything, returns a clean namespace object. Now we have a sample code here, Python args, topic args, platform, args, API key. This structured format makes the rest of the code cleaner, easier to read, and less error prone. Now, how this fits into the overall workflow. This function sits on the very start of the execution. The flow looks like this. First, the user runs the script. Second, arguments are validated. Third, clean inputs are passed to generate the post. And then the fourth and last one, AI generates and delivers the content. By the time the AI model is called, all the inputs are already valid, clean, and expected. This is how you build predictable AI systems. Now, let's go through the key takeaways. This function doesn't touch the AI logic, but it is still critical. It ensures human-friendly interaction, input validation, and safer execution. In AI systems, good input handling is just as important as good prompting. Now, we have the last code segment, which is the main method. Let me highlight that. Now, this particular main method is the final orchestration layer for your project. Nothing new is being invented here. Instead, everything you already built so far is wired together cleanly and safely. I'll explain you how the whole system actually runs. What main method represents, which is definition, main argument, list of strings, int, and this function is the entry point of the application. Its responsibility is not to write prompts, talk to the model, or generate content. Its job is simple. It is to prepare the environment, validate the inputs, call the AI logic, handle failures gracefully, and return a proper exit code. This separation is intentional and professional. Now let's go through the steps. Step 1. Loading the environment variables safely. This line loads the env file only if it exists. Key design choices here are: the path is resolved relative to the script itself. It does not depend on the current working directory. The script does not crash if .env is missing. Now, why this matters? It works consistently across machines, supports local development and production environments, and it avoids "it works on my machine" problems. Now, step number 2. Passing command line arguments. At this point, user input is validated. Required values are guaranteed to exist. Platforms are already restricted from here onward. The code can assume inputs are well formed. Now comes the step number 3, which is about resolving the API key. This line implements a clear priority order. We can use the API key passed via command line interface, otherwise use the environment variable. Now, why is this a good design? Explicit inputs override implicit configuration. Flexible across environments, no hidden dependency across globals. Now comes the step number 4. Failing fast. If the API key is missing, instead of letting the model fail later, the script detects the issue early, prints the clear error message, exits with a non-zero status code. This is a classic fail fast principle. AI systems should never attempt execution with missing credentials. Now comes the step number 5, which is executing the AI logic. This block protects the system from prompt errors, model errors, network issues. Instead of crashing, errors are caught, a clear message is printed, execution stops cleanly. This is especially important in command line interface tools and automation pipelines. Now we have step number 6, which is handling output encoding correctly. This section exists for very practical reason. Social media content often includes emojis. Some systems, especially Windows, struggle with Unicode by writing UTF-8 explicitly. Output remains readable. Emojis don't break execution. The tool behaves consistently across all platforms. The fallbacks ensure the scripts still work even in constrained environments. Now comes the step number 9, which is about exit codes and script entry point return 0. Returning the numeric exit codes allow shell scripts, CI pipelines, automation tools to understand whether the command succeeded or failed. Now, this line ensures the script runs only when executed directly, passes command line interface arguments into the main method, and exits cleanly with the correct status code. This is a standard professional Python application structure. End-to-end execution workflow in a big picture. Here's what happens when someone runs the script. Environment variables are loaded, inputs are parsed and validated, API credentials are resolved, platform-specific prompt is selected, Gemini model is initialized, LangChain executes the chain, and output is printed safely. Each step is isolated, predictable, and easy to debug. This is exactly how reliable AI tools should be built. Now the final takeaway. This main function is what turns a collection of AI components into a usable, production-ready tool. It demonstrates an important lesson. Good AI systems are not just about prompts and models. They are about input handling, configuration, error control, and execution discipline. At this point, you've completed a clean end-to-end LangChain project that moves smoothly from theory to hands-on execution. And that brings us to the end. And with that, we have reached the end of this session on LangChain Course for Beginners. Should you need any assistance, PPT, datasets, or any other code documentation related resources, please do let us know in the comment section below, and our team of experts will be happy to assist you. And if you found this video helpful, don't forget to like and subscribe for more AI insights. Thanks for watching. Until next time, stay tuned for more from Simply Learn.